Hello everyone, I'm very flattered to see so many people here today. Thank you for your interest. And today I would like to speak a bit about HTML5 game development, how we could use them in our company. Yes, please come in. How we can use them in our company, and that game development isn't as hard as most people believe. But it is with its own challenges. So, and the main purpose of the games that we can use in our company is games as a marketing tool. And what does that mean? What do they give us? They higher the level of brand awareness and brand engagement of the customers. Advertisement games have a chance to go viral. Like, for example, everyone knows the mini game in Chrome when you lose connection, the dinosaur running. Yeah, so the games have a chance to go viral and to get widely spread. And games provide additional marketing metrics. From these games we can see what people like, what people dislike, get some information that we couldn't get otherwise. But what about the customers? What people are attracted by games? On this part I would like to get your opinion. So, oh, I forgot the link, sorry. Well, I will ask you to get your phones and open a link and vote. What do you think is the average game of the majority of the players? And the link is, yeah, so please open this link on your phone and vote. What do you think is the average age of the majority of players, of people that are considered as gamers? Yeah, this is working. So there is a major part of you that believes that the majority of gamers is underaged, that they are minors. Okay. And 70 to 30, okay, sure. Now, what do you think about the education of the average gamer? Okay, so we have a battle between higher and school level. Someone voted for preschool but cancelled. I saw that. Why not? Why not? Absolutely. Okay, sure. Now, the majority of votes was that the age of average player is or underage or 17 to 30, and the education is only at school level. However, the statistics show that majority of gamers have higher education, and that the age of gamers is spread across all ages, and that underage is pretty small part of it. And from this we can say that games attract paying customers, that customers that can get involved, for example, in our company. So the main usage of games in marketing is to get some special offers, to promote something, to get people associating events to your brand. For example, you can make a mini game. It cannot give player anything, just something silly to do, a time killer, but you can do it for Christmas, for Easter, for example, and people will connect the joyful, the cheerful feelings of celebration to your company, and they will likely use your products. And also, games can get us social media integration. For example, if a player can win something, we can also offer him to share this information, for example, on Facebook. Some people do, and thus more people see about our company, hear about it, and eventually buy something. Yeah. Here are a few examples of brands that are already doing it and doing it successfully. You all know that Google does pretty much on every major event doodle, and sometimes they are in the form of a mini game. Like, for example, for the Olympics, they had this mini game when you need to play basketball or to be a runner. But there's also a local example, Circle K. They have just finished their campaign with a scratch card game. When you needed to scratch some area, and if you had 3 items that are the same, you would win a big discount or get even something for free. And this marketing pretty much works, as I have as well for this. Once I have won a brownie for free, and I went to get it. But it was pretty small, and I also brought 2 more. Because, well, I'm a grown man and don't... Okay, sure. But the point is that from the beginning I wouldn't even buy anything from them, but since I won one for free, I brought 2 more. Like that. So let's get to the development part. And the main technology that I will be focusing in is Pixel.js. So what it is? Pixel.js is a WebGL canvas rendering engine. It switches from one technology to another when it is needed to provide optimal experience for the user. But it is not a game engine. It only renders graphics. It has very good performance. That's why I would advise to use it. And there is a popular misbelief that online games are slow in their performances, that they are laggy, but that's not the case in this situation. And when I say that it is fast, I mean like it's really, really fast. And to demonstrate that, we have this bunny example. Well, some of you may not see it, but there are 2 rabbits jumping on the screen, and there is frames per second meter. We have 60 frames per second at the moment, and we can add more bunnies to the stage, like this. Okay, so now we have 4,500 of bunnies jumping on the screen, and we have still 60 frames per second. Let's see how far we can go until the frames will drop. So 30,000 and 55. Okay, as you can see, when I'm adding them to the stage, the frames per second starts to drop. And okay, while showing the presentation on a big screen, this computer can render 84,000 rabbits hopping on the screen simultaneously, and only then the frame rate will drop. Without showing the presentation, I managed to pull off 100.5 of bunnies. My phone managed to render 100,000 of rabbits simultaneously until the frame rate drops. Well, yeah, that's pretty great for a web technology. Okay. So, why not to use a game engine? Because, as I mentioned, it is just a graphic rendering engine. Well, the first reason is that engines are quite heavy. They provide more functionality than you will ever use. And for example, if we do the same thing that Circle K did, the Scratch games, we don't need functionality for collisions, for example. We don't need the functionality for dynamic object creation and so on and so on and so on. It's a lot of functionality that is included in game engine and is included in the end product that will never be used by you. Well, you may use some, but you will never use everything. So yeah, if you want to go light, you go with your own system. Game engines have limits. Of course, they provide a lot of functionality, but when you need to go even further, when you need to do something custom, there are limits that you just can't break with a game engine because of how they are built, because of their code. You just have to do some magic to pull off anything outside the borders of the engine. And of course, everything best comes at a cost. Same goes for games engine. There are many ways that they monetize people. First of all is a fee that you play only once, but they also offer situations when you pay a percentage of your income. That is also not a convenient thing. So, what can be considered a game overall? Well, there is two major types of games, and one is not skilled based. Basically, it is a game when your actions do not change the outcome of the game. Your actions only push the game further, but the end result is the same, not depending on your actions. For example, lotteries, idle games, clickers, slots. Your actions cannot worsen your outcome of the end of the game. And there are skill-based games. Basically, it is everything else when you need to show some performance, when you need to act somehow, and you can lose or win depending on your actions, and so on. So, the majority of advertisement games, they are not skill-based, basically because they are simpler in development, a lot simpler in development, and some people ask, well, like, I want to make an advertisement game, but I'm too afraid to give something to people to win, because I'm afraid that I will lose money in the end, that too many people will win and I will be in minus. For example, if I have 10% rate of win, like some amount of players are playing and they all can get in that 10%. And while that is true, there is also a law that prevents that, and it is a big number theory. And to illustrate this, I will make a situation. For example, I am making a game when some people pay a fee, throw a dice, and and they get back money like the amount of they have thrown on the dice. Like for example, if I pay 4 euros, I throw 6, I get 6 back. That is 2 plus for me. Okay, so in these situations, people may throw 6 all the time, but there is a law that says that when you increase the amount of tries in probability theory, then the average outcome per player is getting closer and closer to the calculated one. As we see in this simulation, the calculated outcome of a throw is 3.5 average. And yeah, there were few throws below, few throws higher, but in the minimum it gets closer and closer to the calculated value as you increase the number of throws. And this is only 100 throws, that's not a lot, but as you can see, the average outcome is already pretty much close to the calculated. So let's get back to the development. One of the main issues that come across the game developers' mind is collision and collision detection. It is quite a challenging problem. It has its own underwater rocks, if you would like to help like that. And for example, I will show you how to get a circle type object collision.
Sorry, could you please use the black one?
Yep, sure. Like if we have two game objects that are circles, almost circles, okay. Then to understand if a collision has occurred, we need to get the radius of both of them, sum them, and compare it with this vector. And it is the easiest type of collision, like the most primitive one. But what if I have square type objects? It's pretty simple nonetheless. But what if I have polygon type objects? What if I have 3D objects or objects with some custom shapes? Well, this is when the tricky part comes in, because you need to separate your object in primitives and calculate the collision of each of them, of the primitives. And there is a discussion here, because some of you may have noticed that in some games, when an enemy hits you, like the strike goes past you, but you take damage nonetheless. Why does that happen? Well, because of this issue. When we divide to primitives, there are some places that are not covered by the collision detection and or go outside the character, and you need to find the optimal point when you separate the object in primitives enough times so the game is not clunky and it is convenient for the player. But you need to do it not much times, because it drastically can influence the performance of the game. You can divide the character in infinite amount of simple shapes, but you need to detect collision of each of them, and it takes computing power. So yeah, I have another interactive example. Let's assume that we want to make a game like shoot balloons from a slingshot. Something similar to Angry Birds, but we want to not kill pigs, but pop balloons. So let's draw the situation. We have a slingshot. We have some balloons flying. And we have a rock or a bird that we want to draw. So the trajectory will be something like this. And we need to calculate the position of the bird in a time. We need to understand the trajectory that the bird will fly. And we can do it, for example, from this formula. Those who remember physics are the best developers for game designs, because there is a lot of physics and geometry involved in game development. So yeah, basically we know from physics that flying objects use this formula to calculate their position. And I have made a bit of a challenge for myself to demonstrate this. I spent 1 hour developing a game with a similar gameplay, just to demonstrate how easy it is. I should say that I have tested it only on this type of resolution, and that I feel that it will not work as correct on the TV. Well, oh yeah, this works. Well, yeah, so we have a game when we drag the bird and we draw it. And we try to pop balloons. Well, yeah, that took me an hour. So, as you see, the game development is not as problematic as you may think. Of course, there are many things that can be tweaked in this. And don't mind the graphics, I'm not a designer. Yeah, well, so we can move on. In this example, I was using this formula to draw the trajectory of the bird, to draw its position. But there are some tools that provide this functionality, that provide animation to the objects. And one of the most popular is Twin from Greenstock. Probably you may have heard of it. But basically it is a very powerful animation tool. It provides great control over the animations. It provides many configurations for the animations that would take hours to code manually. For example, easings, loops, timeline control, and so on. So, yeah, this is to demonstrate another example of wheel of luck. Also, 1 hour in development. And this wheel is animated using Twin. And as you see, there is an easing on the wheel. Like in real life, it turns and gets a little bit back. And the scroll is also animated by this thing. And the thing is that to animate this manually, it would take me hours of development, while I have completed this in 1 hour using Twin. So again, we spin the wheel, yay, we have won something, and like this. So let's move onward. Let's talk about the graphics a little bit. So, starting from the basics. In web games, we use mostly 2D graphics. Of course, you can use 3D graphics, but it's not worth it, because Browsers do not support high-end 3D graphics, but nowadays using 3D graphics from 2000s is not quite so appealing. So basically 2D is your go-to variant in this case. But that does not limit you to style. You can use pixel graphics, you can go for cartoony something or for photorealism. Everything goes, you can express yourself as you want. On the market there are some experiments with vector graphics. And boy, do they fly. But in the cost of very expensive development, it is very hard to develop a game using only vector graphics. But maybe sometime in the future we will move towards that goal. Pixel.js, the rendering engine that I mentioned, it allows to draw primitives. It provides some filters and transmutations that you may apply on your images. And there are some advantages of using this engine. Also, it allows to style fonts and use any different fonts. And it has bitmap font support. Well, bitmap fonts is basically when you create your own font using raster images. You can draw letters and tell a program that this is A, this is B, this is C, and so on. And you will have a dynamic text that will look as if it is drawn, but it is dynamic. But there is a downside for this. If you are translating your game to any other language, you need to keep in mind that some languages have special characters, like umlaut in Germany, and you need either to draw them as well. And it is okay if you have limited language supported, like for example English and 2 more. But if you have a lot of languages, you need to find a font that is a regular font that is similar to your bitmap font, so you can replace the font if the text is not on English or the language that is supported by your bitmap font. Okay, that was the basic. Is the distance between 2 images. And the best practice is to use 2 pixels. While in our company I have noticed that we use only 1 many times. It is okay, but there is a problem in computer working, the floating point error that is called, and sometimes the pixel of an image may get trimmed because of this computing error, depending on the way that your device graphic card is, what algorithm it is using to compute graphics. Yeah, and another step of this graphics evolution is to use spine animations. What is spine animation, you may ask? Well, there is this demo. Basically, we have seen sprite sheet animation, and it is changing frame from frame of the character. But spine animation, it divides the image in some parts. For example, if it is a character, then you can use separate limbs, even move eyes separately, and animate the image by moving and transforming these parts. And when we compare with sprite sheet animation, they are pretty much equal if we use only one situation. But the sprite sheet image is already 18 times heavier than the spine animation. Why that? As I said, you need to store each frame of the animation in one case, and in spine animation you need to store the assets of the character only once and then animate them. It goes along with a small JSON file that dictates these animations for the program. And as visually they look pretty much the same if we use them as intended. But what if we decide that we want to have a sneaky dinosaur? and we reduce its speed. In sprite sheet animations, we see that the animation is built from the frames. We see each separate frame, but in span animation it's working smooth as intended, because basically you don't have each frame separately. If you would wish to accomplish this smoothness for slow animations in sprite sheets, then you would need to store an enormous amount of frames in your animation, and it will be like many times heavier. Yeah, so let's move on. Sound. Well, there is not a lot that I would like to tell you about sounds today, because first of all, we have time limit, and I believe that we don't have sound operators in our company, at least not here, so let's move on. Well, basically you need to use sound sheets just as for images. You can combine different sounds in one file and download them as a pack, and programmatically then play some parts of the sound file as a separate sound. There is many libraries for sound management, so that is not a problem in web development. And the sound is really important for the game, for feeling the game. You get immersed in the game if you have sounds, but if you don't have sounds, you get less immersed. You need to have outstanding graphics. And also sounds may be used as an indicator for the situations when you don't have an animation. For example, I did not have an animation for the balloon pop and for the time when the bird flies out of the screen. But there is a sound indicator, so you understand the situation happening on the screen. So yeah, and just for funsies, let's play one guessing game of the theme songs of the games. And that is to demonstrate that sound is as important and as memorable as the game itself. So feel free to answer if you know the theme. So, you know the game, yes? It's Super Mario. What about this one? Yeah. It's World of Warcraft, from the good old times. What about this one? What? Someone said something I didn't hear.
It's Zelda.
Yeah, it's The Legend of Zelda, the Nintendo game. This is one for the girls?
Super Mario Odyssey.
No.
Sims 4.
Yeah. I'm surprised. Well, you got the part wrong, so it's okay. Yeah. Gamer detected. So yeah, basically the song is the sound of the game. It is as much important as the game itself. It gets remembered, and you remember it abstractly from just hearing the notes. Actually, in game development, there is a lot of place for discussions. There is ethical questions. There are basically every topic that I covered in this lecture deserves a different lecture for itself, or even more. But it's another story. And before we finish and go to eat pizza, I would like to ask you complete one more voting. How did you like my presentation? Oh, thank you, guys. Well, yeah, that's all that I have for today. Thank you very much.